Our final project, we used wind farm data, which provides 20 wind generating assets. We developed an application that provides predictions and visibility to monitor the windmills based on their energy generation and production to provide transparent insights into the operations and understanding of windmills.
Thanks, Michelle. So let's take a quick look at the front end of our API. Here we forecast wind power production for the 20 windmills, as you can see here. For the model, we use historic data, and we also take in a parameter which decides the number of hours to forecast the wind power prediction on. So these three variables can help us decide on which parameters to be selected for the model. So suppose we say we want to predict for the next 3 hours, we just select the number of hours to be forecasted as 3. And our model would automatically predict the wind power production for all these 20 windmills for the next 3 hours. And now we can filter the wind power production based on the high, medium, and low categories. So suppose we just want to see the wind powers that have like the highest wind power production. So we'll filter it out that way. And we'd get a list of all the windmills that have the highest projections. Now, if we want to specifically go and look at one of these windmills, say this one, we can select this number right from this page. To support our visualization, we have also added the wind speed of that location for that day. We can select the location and the number of days to understand the wind speed from these. And this would allow us to get a more comprehensive understanding of the wind power production for that mill on that day. And next up, Anna will help us understand the architecture of this API.
Thank you, Eamon. So the front end we just saw now is the end user on the left side of our architectural diagram. And in between our front and back end, we have set an application load balancer as part of best practice. We have also split our application into 2 Dockerized microservices, one of which is to manage the prediction data stored on S3, and the other is to pull directly from an external API on weather data. And these Docker containers are running on Fargate and orchestrated using Elastic Container Services, which are available in 2 availability zones on AWS. The model we are using can be triggered using a cron job, which can be scheduled if we have continued sources of data, though now our static data is just sitting on S3. And the model we chose is the AWS Deep AR model on SageMaker, which is specifically good for time series predictions. And these predictions are then batch transformed, pushed to S3, and then pulled by our front end. We have also set up a continuous integration and deployment using a process using code pipeline, where any code updates on GitHub will be pushed directly into production. And next, we'll give you a quick technical demo.
A couple of concepts worth mentioning from the architecture that Anna mentioned is the step function, which is responsible of the automated training the new model based on the new data, then save the model and push the prediction to the S3. Another important concept is the functionality is the code pipeline, which is going to run a new process once there is a new information, new data in a Git repository, and is going to push the containers to the Elastic Container Registry. And once there are new containers, the cluster is going to run the new task and serve the new model for based on the new containers. This is all. I will pass to the Ryan for the conclusion. Thank you.
Thank you very much, Tigran. With our model architecture and web application, we can predict wind energy production, visualize the data, and decide which windmills to operate in order to maximize the production. The architecture we built can be utilized in many different ways and be easily applied without making major changes. Thank you very much for listening.